Hey guys, how's it going? So last time we were working on the transport network. I reverted it back to just dealing with the splines for each network. In the meantime, I've gone ahead and added some debug drawing. So we'll get some different colours for the different networks. So our pathway, the rail, a different colour there, the road, the yellow, and the taxiway be a different colour, so we can at least visualise where those different networks are going to be. What I'd like to do next is deal with junction detection. So if we come around and we start overlapping, we want to start detecting where junctions are going to go. For now, I'll just debug draw a point where we provisionally detect a junction. The method we're going to use isn't going to be super accurate just yet, so it'll be a rough start, but we're going to work on the accuracy a little bit later. But basically the way it's going to work is we're going to loop through each of the splines for all of the networks. For each point on the spline, we then loop through every other spline and we find the nearest point on the other spline. So for example here, so we'd kind of loop along each point, and let's say we're detecting this spline here, we'll find its nearest point on that spline to the current point, which in this case would give us this location here. We'll then have a threshold. So for example, if it was this one here, if it's outside of that threshold, we'll ignore it. If it's here, for example, and inside of that threshold, then we'll, for now, treat that like a junction, and we'll just, for now, draw a debug sphere or something. Yeah, we'll draw a debug sphere just to mark where it is, and then we'll do some testing just to see the accuracy of it, and then that will be preparation for actually implementing junctions. The reason why I want to do overlaps on all the networks and not just individually, there might be cases where, let's say we've got a road and then we've got a rail going across it like so. We want to detect that overlap between the two different networks and create a suitable junction. So it might be like a rail crossing, for example. So yeah, so we're going to be overlapping over all of them. And then just give you a sort of slight overview there. So the network manager is the one that instigates creating the segments. So that would be a good entry point to actually run the junction detection. So do that there. And this is kind of the steps we're going to be following. So we'll get all the splines in the world. So all the segments that make up the different networks. We'll define a junction radius, so that will be the threshold. Loop for each point of each spline. So we'll loop through each spline and go through each of their points. And then for every other spline, well, we actually want to do that the other way around. Let's do that. Cool. Because we want to, so for each spline, loop through every other spline and then do the detection on each one. Yeah, go through each point of that spline, and then with the other one, check the nearest point. Check for the distances within the threshold, and for now just draw a debug sphere. That's kind of roughly how that's going to work. Also going to make a slight change to how the segments are spawned. So at the moment, close that. At the moment, in the network items, for every segment we create a child actor component of type transport network segment. I might change this so we actually just spawn the actor in the world, and then the network item just adds it to an array and is able to keep track of that. So I might do that. Yeah, so that's kind of the plan for today. Ideally, if I can get that done, that'll be all good. And hopefully by the end of this, we'll have some like spheres being drawn where the junctions are being made. So let's start by changing this. So instead of making the child actor components, we just spawn those segments in the world and go from there. So if I comment this out for now. So we want to, instead of creating a child actor, we'll just spawn it. So spawn actor. That's going to be of type a transport network segment, and that should be fine. We should be able to store a pointer to that for now. New segment. Okay, so that should actually spawn the actor in the world, and we'll check that it's valid. Otherwise, new segment, initialize segment, that should be the same. That should, in theory, that should be enough to replace that for now. Let's just test that. Then what we'll do, we'll make an array to keep track of pointers to that, just in case we need it. That should give us what we had before. Yeah, cool. Alright. Halfway. Yeah. Road. No. And takes away. Cool. Alright, sweet. So that's working fine. We can now, let's do this. And then we'll create an array of those. A transport network segment. Cool. Then, so it needs to be an array of pointers to it. So T object pointer. Yep. Okay. Then we should be able to add that now. Network segments dot add new segment. all good. And we're now going to start seeing a segment chain up here. Great. Okay, cool. Right, so that's the easy bit done. So we've done this now. Get rid of that. Now in the network manager we need to actually create this. So let's go here. So it's going to be call it detect junctions. And we're going to call this after we create the new segment. So create network segment gets called. We actually create the network segment, and then we detect the junctions. Then, okay, so if we take a look at this code, this is close, but I don't think it's quite right. So we should be able to get all actors of class, so that should be fine. Then we want to iterate over all of the networks, that's fine. We do want to make sure that we're not currently looking at this isn't quite right. So we need to actually iterate over, we need to like do a loop inside of a loop. Then this is going to be the right thing. So it'd be like for each of those actors, we need to make sure it's not the same one. Then something along the lines of that, make sure it's not the same one. Then overlap point, check spline overlap. Where are we getting this from? Yeah, so we'll use this as a bit of a guide, but it's not quite right. I think some of it we can use. So T array make sure we've got that included. Which we don't. So we need to include gameplay statics. Cool. And that should be here. Okay. Okay, so then we can loop over those. Let's first cast it to, actually no, not much. So 4. Okay, so then we need to do the same for the inner. So this will be the other spline. Mind you, actually, do we need to do that? No, hold on. So that's not necessary. Let's change this to that. So we don't need to get all the segments again. We just need to loop over them. Segment outer. Okey-dokey. Cool. Now we can do the transport. Check that they're not the same one. Alright. Okay, so that's fine. So just taking a look at this again now. This overlap point. Okay, so it's returning that overlap point. Okay, that's fine. So we can create that. Let's call that junction location. then we can create that method. Include spline component. So taking a look at this again. Let's run in the check on the actual spline component itself. So what we need to do is, inside of the loop, get the spline from the segment. If we take a look at the segment, so we need to get the segment spline, and then we need to pass those both to that method that we're going to create. So let's just do that from now. Let's create a get method for the spline. Okey-dokey. Then while we're here, we need this. That's an engine. Okey-dokey. Let's do, because we're going to cast these. Okay, so we can do debug object pointer, a transport network segment, segment outer equals cast, so we're just casting the actors to the network segment. In theory, it should be valid. So that should never be reached, really. Then do the same in here. So T weak object pointer. Segment inner equals cast. And again, it really shouldn't fail. So now I can get the spline component. Outer spline equals segment outer get segment spline. Okay, so now again a pointer to both of the splines. Great. Then now we can actually write this properly. We need to forward declare this so we can use it. Engine forward declares class spline component, and that should show up here. There we go. Okay, outer spline. Inner spline, and then the resulting location. Right. Let's check that compiles. That seems to be a false error warning. No. Let's do that. Yeah, that's fine. Okay, cool. So just a false warning. So let's just do a call the method for now. Check spline overlap. Outer spline in a spline, junction location. And actually we can just go ahead and draw debug sphere. Junction location, radius, let's do 15, 12, color, yellow, true for persistent lines, -1, 0, and let's do 5. Okay, so that should draw a debug sphere at the junction location if this returns true. And for now, let's just make sure we are receiving this log. So just keep an eye on the upper log at the bottom. Cool. Okay, that's cool. And so let's get rid of that. Cool. So we're currently looping over all the splines and then looping over all the other splines, and then we're then going to do an overlap check between those two splines. So that's the next bit. Let's take this. Okie dokie, so let's take a little look at what they've proposed here. So that check should have already been done, but we can do that anyway, just to be safe. Overlap threshold, okay, so that's the threshold for us detecting a junction. Then we go over all of the spline points, segment spline, yeah, that's the bit that's missing. So the outer spline, get the number of spline points, get the location at each of the points, okay, closest point on the other spline, okay, so yeah, that's fine, and then check if it's in that distance of the threshold, okay, that's fine. Let's also make sure this is correctly initialized. Just be safe there. Okay. Let's actually add the threshold to here. Up here. And now let's do 100. So now we want to go over all of the spline points of the outer spline. And then get the location of the current spline point. We will grab space. Okay. So now we're going to get the point on the other spline that's closest to that current point location. Point location closest world location. Yeah, cool. Passing in that current point location. World space again. Now we need to check the distance between the two. Yeah, okay. Closest. Okay. So if the distance is less than the threshold, then overlap location equals current point location, closest point, oh. So I think that's just getting the 2 points, just getting the halfway point between them two. And then we can return true. Otherwise it returns false. Okay, that should actually just work already. That seems to be okay. Let's check that out. Interesting. It's weird. Alright, well it's doing something at least. Let's maybe draw these here. So draw debug point. Let's do draw debug sphere. And we'll do the same for the closest point. Let's do that. Be like blue. So drawing a yellow one where it thinks there's an overlap, a red one where the current point location is, and a blue one where it thinks the closest point is. So we'll make sure that they look correct. What was the blue one? Closest point. But it's in the red one. I'll make the red one a bit bigger so we can see it overlapping. Let's do 50 and 75. Bring this down a bit. Just wondering if that's correct. That should break out of that loop. That's correct. All the code seems correct. I don't really know why. So the blue ones are the closest point. What I would expect to see is a blue sphere here and a blue sphere here. Because as we check on this one, every single point, the closest point of this line would be here. And vice versa, when we're checking the first point, every one of these points, the closest point is going to be here. So it appears to me that that is incorrect. Almost seems as if it's doing a check on itself. Yeah, so we should be skipping. Just for now, just to test, let's do the nested loop. Tap Enter. Pull this in there. Just to make sure we are actually properly skipping itself. Still alright. Oh, I see. Well, that's one issue anyway. Suppose that didn't give a component. Okay, it's kind of working. Man, that's really slowing down. The main thing I was noticing there was it's creating junctions where the segments kind of join up, which makes sense. So that's fine. Okay, cool. Yeah, it's not super accurate when it's a little bit further away. Let's increase that threshold to 100. But this does seem to be kind of roughly working. What else do they have to say about that? Yeah. So we got rid of that anyway. Okay, that's fine. Cool. Let's detect any junctions there and there. Then if I do another network, yeah, so it's detecting junctions between two different networks. Cool. So we'll have to do a bit of optimization to make sure it's at the same location. And at the moment there's going to be 2 at each place, which is kind of to be expected. As one detects the other, it should pinpoint that location. Might just make a threshold again. Alright, that's fine. Cool. Cool. Alright, sweet. Okay, so that seems to be roughly kind of where we need it to be. Cool. Probably bump up the threshold a little bit. Looks like here. If they would do like 250, that should be okay. Let's check the inner and outer splines are valid, just for safety. Keep it in the same order. False. Okay, so that's fine. So we're checking that the outer and inner spline aren't the same. We're checking that they're valid. We're then iterating over all the spline points of the outer spline, getting the current location of the spline point at that index. We're then getting the closest point on the inner spline, so the other spline, and then we're checking the distance between those 2 points. If they're less than the threshold, we'll get the location in between them, and we'll return true. And yeah, we're setting the overlap location to the midpoint in between. If we haven't returned at that point, we'll return false. Now, is that going to detect multiple junctions? If we're returning immediately, no, so as soon as it detects one, it will skip the next one. So we might need to modify this a little bit, but do that next time. Cool, so yeah, hope that's been useful for you so far. I'll leave it there for now. We'll start working on the accuracy next. I'll deal with that issue with like skipping over multiple overlaps, and then we've got the groundwork needed for actually making junctions, mainly for roads really. So cool, so yeah, have a good night, see you later.